Good morning, one and all. Today, we will be talking about Android and something that's out of box, something that we don't usually see Android doing, which is we will be looking at how Android can be used for industrial environments. So that could mean factories, warehouses, manufacturing lines, or anything along the lines. It might sound a bit intimidating and a bit hard, but I will try to make it as simple as possible. So to begin with, I work mostly on the backend side, but I'm trying to figure out how Android devices can be used for hardware or industrial sort of things. And my realization has been that Android has been very powerful than just a few years ago for industrial works. Let's picture this. You work in an IT company and you have some sort of factory, and you will see that a lot of factories use legacy Windows XP, and they have proprietary hardware. Proprietary hardware means you have to have a vendor lock-in. That means you have to make a contract with the company, and it's really hard to make changes with them later because you pay them and they do it, but it's a very orthodox method. And the biggest problem is you need their hardware and you need their software and their consultants, and simple changes can also take a long time. So to work with this, I figured out that maybe Android could be a good bet. So how it works is Android hardware is very robust, and the OS is very stable, and the ecosystem is mature. And a lot of Android tablets and devices have the potential to be used in the factories and industries. So that means you don't have to necessarily use the old hardware if you know how you can make use of Android with the factories. We'll be looking into it in a bit. So one of the biggest questions would be, why hardware? Why Android? Sorry. So first, like I said, the ecosystem is massive, and there are millions of Android developers worldwide, including all of you. And that means you're not locked into a small pool of some specialized programmers. Second, hardware availability is incredible. We have $200 tablets, and we have $2,000, huge devices. So that means it's quite versatile. Third is the developer familiarity. That means it's easier to maintain. We can always push some pull requests, and we have so many good and amazing developers around to work with. Last, it's not about hardware because it's not as expensive as in terms of scaling to work with Android. Now, let's briefly cover what we are going to talk about today. We'll be first talking about Android's hardware capabilities. That means how can we actually make them use with industrial equipments. Second is, what are the different connection approach you might have or you might want to do. Third is, how can you use Kotlin Multiplatform to work with Android and industrial devices. Fourth, we'll be looking at some real-time implementation patterns. And last, we'll be seeing some real-world considerations because it's sort of experimental, it's not the best. So we have to go ahead with a step of precaution. So let's start with the first one. So if we think, how can I connect my Android to the hardware devices, we usually think it's three things. You can use a USB, it's direct, very reliable, and it has the lowest latency. And the nice thing is Android is permanently, glued to the equipment, so there's no stress about losing it. Second, we all know Bluetooth and Wi-Fi, they're great for mobiles and for situations where you cannot use your cables. Last is something that we'll be looking at today. It's a hybrid approach, how we can use some web applications to communicate with Android through the browser. It's experimental, it's not very production ready, but I think it's good enough to give a try. So first, like I said, we'll be looking at each one of them. So first is USB connection. It's a very simple code. Your Android has Android supports USB since I believe, Android 3.1. So that means you can use it for barcode scanners, RFIDs, PLCs, or anything. So the code that you see here, it's a very basic approach. First, you enumerate the devices, and then you find the hardware by ID, by vendor ID, and then you open the connection. And of course, the actual implementation is a bit more complex, so I've tried to keep it more concise, but you can always look at the API documentation given by Google, and Mozilla Firefox has good resources on it. For this sort of code, usually latency is typically under 10 milliseconds, and the data rates can reach up to USB 3.0 speeds. This is good enough for real-time implementations. Next, wireless patterns, that is Bluetooth and Wi-Fi. So you don't always have to carry wires with you. So this sort of equipment with Bluetooth and Wi-Fi is very good for sensors like temperature, humidity, vibrations, or any sort of monitoring of those kinds. And it works best for higher bandwidth needs. And the code that you see here, it's again a very basic connection pattern. Most Android devices can handle a much more complex code. So for this, the connection is typically established in seconds, and it can reach around, I believe, 100 milliseconds with class 1 Bluetooth. Now the next one, I was talking about 3 categories. The next is the hybrid approach. We'll be looking at a web serial connection. So we'll be coming to this in a bit, but let me first tell you all what is a web serial API. So we have some sort of an architecture. So if you have an Android app, how can you make it work with the hardware? First, you have to use a web view, and you use a JavaScript. We'll be coming to the JavaScript part in a bit, because that's the complicated part of making Android work with your sensors or RFIDs or Raspberry Pis. We'll be looking at first the web serial API. Most developers today do not know about it. It was released by Chrome, by Google in Chrome 89 in 2021. And the main point is it requires user permissions. What that means is first you have to use a device picker. The user has to select a device, and then you have to give it access to that session. So that means it has a lot of user permissions. It's a little bit bothersome to do it every time. If you talk about browser support, it's only Chrome and Edge. Firefox and Safari do not really support it. And if you want to use it with Android, you need to enable a flag in Chrome. But despite its limitations, you can use it for Arduino or IoT devices or educational purposes. And there's a lot of APIs being developed very rapidly on GitHub, which is a good starting point. But now you might ask me, how does this compare to, let's say, USB? Why do I have to use the web serial API and not the USB connection? So first, let's look at the limitations. The number one is you always have to use HTTPS, and it requires user gestures. That means the user has to manually select the device and all the different settings, which is a bit bothersome. And there's platform restrictions that we just talked about before. So in case somebody's wondering how is the limitation with USB, web serial is cross-platform, and you have no app installation. But again, browser limitation, and it has limited support because it was only released like 3 years ago, and there is work being done, but there's not so much, so much of open source contributions being done. For the native USB, you have full control. It's always available, but it's not platform specific, and you always need an app to work with it. And this is how a basic web serial pattern looks like. This is from Google's web serial API. You can find it online on Google's documentation page. It's pretty simple. You request a port, and then you open it with some parameters, and then you start the communication. But please remember that this runs in a browser context with very limited, with a lot of limitations. And this is how the permission model looks like, which is sort of bothersome. first the user always has to click what device or sensor he wants to work with or they want to work with. And then second, the browser is going to show you what devices you have. Third, the user manually selects it again. And then the permission only lasts for that specific session, so it's not something you can use long term. So it is fine for configuration tools, but for production systems, we have to think, how can we make it last longer? So this was all about the basics of Web Serial API and how we can connect different devices. What are the different methodologies to connect USB devices and wireless with Android? Now, let's move a bit towards how we can use JavaScript and Kotlin with this. So it's this is sort of a difficult question. We have JavaScript in our web view, which is reading the RFID data. And we have a very robust logic, which is written in Kotlin. But the question is, how do we connect it? The answer is a very standard Android feature called JavaScript interface. There's always documentation available on it. It's like a magic glue. It's a very safe and official way to expose your methods from your Kotlin code to the JavaScript code. So first, we can go step by step. So first, you have the RFID reader. It sends the data to the serial port. Next, we have the Web Serial API, which we just discussed. It's in JavaScript. So this Web Serial API captures the data that you just got from the RFID device. Next, this JavaScript code is going to call this JavaScript interface. It's sort of like a bridge because it's trying to get the data from the web view, but it's also trying to send it to your Android app, the native app. And finally, you have some sort of shared Kotlin multi-platform logic that you can use. Now let's look at how the code implementation works. It's simple. It's not that complicated. If you look at the code, first you create a small class in Kotlin called Web App Interface. Now we have the JavaScript interface annotation there. So any public method with this annotation becomes callable from JavaScript. So you might notice that we have something called post tag data. This is globally available function from the web page. And then if we move in, we have the activity or fragment. So we instantiate this class, and then we attach the web view using add JavaScript interface. And I just gave it a name. Let's just call Android Bridge. And now your JavaScript can call Android Bridge.post tag data. And this way, the data will appear in your Kotlin code, which is ready to be passed to our view model. So now that we looked at how the basic implementation looks, let's see how we can make it work with Kotlin Multiplatform. So it's quite simple. Kotlin Multiplatform, we all know, it lets you write business logic once. You can reuse it, and you can share it across your platforms. And the benefits are huge. The code reuse, the first one is, writing validations, logic, or calculation, or even our RFID parsing once, and being able to use it again. Second, type safety. You get type safety across all platforms. Third, native performance. That means it's not just a web wrapper. That means it compiles to the native code. And last, you can always start with one shared module, and you can start building on top of it. Next, this is a small example of the architecture. It uses the expect and actual pattern. So you can see we define the interfaces in the common code up, and then we provided platform-specific implementation. That means you get best of both worlds. You have a shared logic. You also have platform-specific optimizations. Next, if you're wondering how the project structure looks like, it's clean. It's quite simple. Your common main has your shared business logic. Your Android main has the Android-specific implementation. iOS has your iOS, and JS main has for web. That means each platform gets what exactly it needs, which is, I think, quite versatile in it. And this is how an example of a shared business logic might look like for our RFID system. So if we focus here, we have a data class for an RFID tag, and we have a parser there for the common code. And if it's a bit complicated, it basically takes the raw hex data from the reader, because usually RFIDs have hex data that you have to convert by yourself. And then you turn it into a strongly typed object. And the nice thing is you only write this once. That means you write it once, you test it once, and you can use it everywhere. And if you're looking for platform specific, it's quite minimal. Usually, it's just simple things like file paths or the platform APIs or UI codes, and everything else is shared. Now that we have covered Kotlin so far and how web serial APIs work, let's look at the system architecture for a bit. It's quite simple. At the top, we have application layer. So this can be your UI or your Jetpack Compose or your iOS Swift UI or your web React if you're using web JavaScript. Next, you have the business logic KMP. So this is where your Kotlin Multiplatform lives. All of your RFID parsing, validations, data transformation, they all live here. Next, the hardware abstraction. This is used for isolating the platform-specific implementations, because the business logic doesn't care if you're talking to a USB or a Bluetooth device. It just cares about the abstraction. So the abstraction is very good to handle it. And last, we have the device layer. What this means is the actual hardware communication. That means you can actually swap out hardware without touching the business logic. And reliability patterns, an industrial system cannot fail. If it crashes, the entire line is going to go down. So this is a bit of retry pattern that I have thought of. So if the first attempt fails, you try again. If it fails again, you wait longer, but you try again. And after 3 failures, you alert maintenance. But the basic idea is the app is not going to just crash and give up, because in factories, usually timeouts are really critical. And if your hardware doesn't respond in 5 seconds, then that means something is wrong. So I think it's really important to have a very robust retry mechanism. And we work in, and if you look at the offline sync, when we work in factories, we do not always have good connectivity at all times, because the walls are huge. You have to walk a long way, and you don't always have good connectivity. So instead of just saving data, we treat every single tag as a state machine. That means it's queued locally first. Whenever the network is available, it moves to syncing. And from there, it can either succeed or fail. But even if it's failed, we know from where exactly to pick it up. So I think it's important to implement a very offline, local first architecture when building these sort of things. If we look at state management, we have a state flow, which holds a current state. And we have the shared flow, which broadcasts events. And this sort of pattern works identically on Android, iOS, and web. The UI observes state changes, and it reacts accordingly. So the main point is, in industrial apps, the state might be a machine system. So we need this sort of a reactive pattern to work with. Next, this is sort of a real-world example. A fast industrial RFID reader can read hundreds of reads per minute. And if you try to update your UI first, the app is going to freeze. And this is sort of a very critical question. And how can we solve it using Kotlin flow operators, for example? So there's a bit of code that I wrote about. So here we have the buffer. We buffer the incoming data first to observe the bursts, and then we conflate so that we only get the absolute latest tag, even if the UI is busy. And it's the beauty is the hardware is decoupled from the software, and I think it's a good user experience point of view. And if we want to use it with Compose, again, they're very minimal examples. I think Jetpack Compose is perfect for industrial UIs. We have something called status indicator. We can show the RFID connection status. Then we have the RFID tag list, which shows the real-time scans. Then we have the control button, which is going to trigger actions like clearing the list or starting a sync. So I think if we work with Compose Multiplatform, we have the same concepts, and it's one UI framework, so it's very versatile to maintain. And if we look at the testing strategy, we have unit tests in common tests for our RFID parser on all platforms. Next, we have platform-specific tests to verify our JavaScript interface that we just discussed. And last, we have the integration testing and UI test. And they are the pretty standard tests that work around. And next, security in industrial systems is non-negotiable. So these are a couple of things I think which can be used for your system. First is device identity. Every Android device must authenticate itself on its unique certificate. Second is a per request authentication. So every single API call must be authenticated from the app. Next is assume breach. Internal factory network is quite hostile. So you have to monitor all of the data incoming and outgoing. Finally, we have data validation. So we have to make sure that whatever data our RFID tag is reading is valid, it's trusted, and if we think it's okay, then we send it to our Kotlin Multiplatform code. And deployment options, we have a couple of them. First is MDM, which is mobile device management. That means the IT team can monitor it remotely and can always shut it down or use it as they wish. Second is private apps. That means your company has sort of like a private Play Store, so the apps never leave your company network. Next, we have the kiosk mode. That means nobody can just exit the app to do something wrong. Last is the OT updates. That means you cannot update during production. Now let's look at the implementation. I believe you can do it in roughly 4 phases. First is the requirements. It's important to understand what sort of data do you want to work with, what sort of devices do you have, what about the failure modes. Next is architecture. You have to think about reliability, offline architecture, safety, and and testing. Third is prototype. So you can always start small, and then we can build on top of it, given that Kotlin is quite versatile. Last is testing. You have to test with real operators. That means even after you've made your app, you have to go offline and try to test it as much as possible. And there are some common challenges. Device compatibility is a big, because what might work on a Samsung might not work on a Xiaomi. It's just an example. Second is network. Factories have terrible internet connectivity, so it's important that we design for a offline experience and a local first architecture. Next is battery optimization. Usually factories, people work for long hours, 12 hours, so it's important to consider it, the battery limitations. Last is update. You cannot force an update while you have factory ongoing, so it's important to maintain the time. And for the problems that I just mentioned, this is just a couple of solutions. So first is testing matrix. What that means is you maintain a list of approved devices, so not every device can just hop on. Second is offline first. Like we discussed, it's important to have a local first architecture. Third is power management, APIs, battery optimization, wake locks, or anything along those lines. Fourth is staged rollouts, like we discussed. You can update one line first, you can monitor for a week, and then if you see it's working fine, then you build on top of it instead of sending a batched update. And if I were to give you recommendations how to start, you can always start with proven APIs. You can start with Web Serial API by Google. You can start with the Android JavaScript interface. You can also start with a lot of hardware and software APIs, which are given by Google and MDN. And I think reliability is very important in these sort of hard conditions. And again, offline, I cannot stress it much. And finally, it's testing, being able to test well. And if you might think, where can you use it in your work or for yourself? You can use it for, let's say, reading QR codes on production line, or process management or asset management. And these are just some examples. In logistics, you can use it for warehouse management, inventory control, or anything around them. But you can also make some small project for yourself at home, because RFID tags are quite cheap, and it's always easy to program with them. And future considerations, these are some points that I personally think are worth being hyped about. So 5G, it has low latency and high reliability. That means we have a good bandwidth to work with. Next, with edge computing, AI is going to come to device. So that means we can use quality inspection with computer vision. So it's like imagining just pointing your camera at a factory device and it tells you what goes wrong. Last is AI or ML, and also AR, VR. So I think a lot of machine learning, computer vision is going to be very helpful for future aspects. So if I were to summarize the points, I think Android is very much capable for industrial use, although most people have little to no clue about how Android can be used for industrial activities, also for your own self, for your personal projects. And I believe Kotlin Multiplatform is very efficient, given how you can use logic across multiple platforms. And third, you have multiple connection approach. That means you can use your USB or Wi-Fi or Web Serial API. And reliability, like I keep mentioning, it's very important from day one to think about it. And to end it, if you're interested more, you can start with Android's WebView documentation and JavaScript interface documentation. I think it's quite comprehensive and well written. And I think Kotlin Multiplatform guides from JetBrains are also good to start with. And for third one, Microsoft and Amazon have good resources, even though you don't have to use their cloud, but I think they have good resources on this sort of connections. Last is hardware SDKs. A lot of manufacturers, they provide Android SDKs, and I think there's a lot of resources to try out and to just experiment which fits your need the best. And thank you. So I think Android can be used for a lot of industry specific and also personal projects, and whether it's manufacturing or logistics or anything like that. Thank you.